Hello. Okay. Well, good. Yeah, whenever you watch this video, welcome to the fourth lectures of the database programming in practice course. Okay. Today, well, I would say that previously we talked a lot about some fundamental stuff. For example, um, the data persistence, how to keep data alive on your computers even you don't have any power, and also how do we organize the data so that it is easy for us, quicker for us to access the data in order to find the answer to the question, right? That are all the basic blocks, like a small pieces of Lego, right? Now today we will try to see in another perspective, the perspective of users like us, right? Or the perspective of developers, the one who develop applications that are working with databases. Okay. Announcement first. Solo project due next week. I hope you have started it. I hope you are consulting your TA right now. I hope you are like 50% done, right? If not, perhaps you might be in trouble, right? Also, I'm flying back to Thailand next week, which basically means that uh, I will not hosting any lecture next week. But next week it will be a lab. Sorry, not a lab, two labs on both Tuesday and Wednesday, hosting by P1 and P&D. Okay, so you need to bring your own computers there, right? So to recap about the previous thing we talked so far, database is basically an organized collections of data. It needs to be organized, right, so that it is easy for us to access in order to gain information or answer the question, right? But what I want to say here is, from now there will be another terminology called database management system, in which people in technical tech fields, they usually refer to database management system. The second terms here, they just call it database, right? So these two terms, you will see this a lot, right? So you need to read the context in order to see whether um, the speaker means either database or the database management system. Okay. All right. I'm not gonna say it right now. What is a database management system? But it will be in the lectures today, right? Also, data persistence and organizations, right? Those are the foundations of data management. So there is another term here, right? Data management, in which we're gonna talk a lot about today. We're gonna talk a lot about it today, right? So, but previously we talked about data persistence, making the data last longer than the program lifetime or the computer lifetime, right? Also, data organization, which is we learn about strategies to organize data. Well, to be specific, organize databases for fast queries, right? And we talk about that in this course. The way we organize data, it's all about structured data, and I would say that throughout this course we would focus mainly on the structured data. And if you look back into the lab, the first week of the lab, people who taught you Google Sheet, right? Those have um, have like a certain fields, right? Certain columns, names, right? And the second lab is all about using Python, writing a code in Python in order to access data. And those data that you access, they are not unstructured data, right? They are structured data, like the CSV files. And that is also the structured data. Imagine that you are doing the lab 2, but the data is unstructured. The lab 2 will be much harder, okay? And for this week lab, polars, right? You're gonna see the data frame things. And the data frame thing is also one kind of structured data because it has a fixed numbers of properties, right? Well, I would rather say the word fields, FIELDS, instead of the word properties. Okay, so data that you are working with have a certain number of fields, a certain number of columns, and you know each column means what. Okay, so again, we're gonna focus on this kind of data, structured data, right? So today's topics it will be about database management. So you know what is database. Now we're gonna focus on how to manage them, how to manage them. Okay. First of all, I do say it explicitly that applications nowadays almost 90% or like it I would say that almost 100% use databases. Instagram, you know, the picture that you post, the story that you posted, right? Those must be stored in a databases, right? In a database. Your profile information, your text, the comments, replies, the DM, those must be in the databases. If not, if they are just store them in, you know, um, in the memories, in the RAM, then what if Instagram, the computer that store all the Instagram data get shut down? All those data are lost, right? So at least it must be stored on the persistent devices, in which we already talked about it in the second lectures. And it must be organized neatly in order to make sure that when you open up Instagram, you can access it quickly, right? YouTube, that is another good example, right? You have tons of videos, right? When you get into your profile, you have your own personalized list of videos. You can also search for a certain videos or the video of interest using the keyword, right? And given the keyword, the YouTube system quickly searches for all, not all, like the most relevant videos given the keywords that you specify. Those are the keywords that you specify are queries, right, for the YouTube system. So if YouTube hasn't organized their data neatly, the search would take a lot of time. So I would say that the major tech companies, when they store the data, they have a very good strategies to manage the data, to organize the data. Okay. Google, this is another one, right? The search box, and it shows us like a list of relevant links, right? Relevant websites, given the keyword that you specified. Right? Those applications, actually not these huge applications, just a small application like the government application. Most of the government applications that you may have used. What else? Um, Maybe a shopping mall applications, right? That they keep your points, right? Your membership points in them. Those must be stored in databases. So what I want to say is almost 100% of the applications around the world use databases. There are some applications that doesn't have database, that do not have database as well. For example, the calculators, a very simple calculators, or the program you wrote in the previous semester, right? Those you haven't stored in any databases, but it works, right? But you know, it works, but they have limited capabilities, right? Using database will give you much more capabilities for storing data for a long time, fast search for the data in a short amount of time, in which that is the reason why many applications tend to use databases. And all those applications, they tend to use databases in common ways. Basically, it's not that common, but we can group it into some commodities, some groups of common usage, right? But the more important thing is that, okay, whatever it used databases, whatever applications or however it used databases, those interactions with databases must not make databases incorrect. So we have new terms here, incorrect. My question that I would like to pose to you is that, how do you know whether database is incorrect? Let's say you're saying that you update your database by adding one more item. Maybe you have a database storing your receipt, right, as a file. And you say that, hey, I add new item into it. Is that incorrect? The updated list is incorrect or not? No, right? It's just an updated list. It should be correct, but how? How to know whether the database is incorrect? Maybe a good example is that, give it a CSV file, you have 3 columns, ID, name, and price, right? But in the price column, you put, I mean, you would expect it to be floating point numbers, right? Or integer. I'm sorry. Or in integers. But what if people put strings into it? Would you say that this is wrong? Or maybe you have a column called years, your birth years, something like that. Birth years, and someone put, my birth year is 9999. Basically, you they haven't born, right? This sounds incorrect, right? But since it is a database, we will not judge. We will not assume whether it is correct or incorrect. There must be someone who say that it is correct or incorrect, right? And most of the time, it is the one who created the database. Okay, so database management basically means that how you're gonna interact with the database, right? How you're gonna the way database management is more like a set of tasks interacting with the database without making databases incorrect. Okay, and this is not an official definitions, but it is definitions that I think it will give you a very clear view of what the hell is database management. Okay, so before we get into the database management or the tasks, we need to know users. We need to know characters, main characters first. So basically, databases, they are typically 2 groups of people. It doesn't need to be people anyway. 2 groups of users, 2 groups of entities that often interact with databases. The first entity is database administrators. These guys are the one who trying to make databases in a good qualities. This is when they say the word quality. Quality here could mean reliabilities, how reliable the database is, how available the database is, how scalable the database is, how efficient the database is, and most of the time, the administrators is the one who define the correctness of the database. So now, if we have the definitions of the definitions of the correctness of the database, then now we can check whether databases are correct or incorrect, right? So database administrator will be the one who define it most of the time, right? I'm not saying that database administrator will be the only person who in charge of this. Okay. Another entity is basically a database user, or the one who read and write databases, or basically the one who use databases. Okay. Well, you may think that database administrators seem to be a human, right? Database users seem to be also a humans, but nowadays, most of the time, database users are applications. Well, they typically are software, and they're typically going to be software. Right, so humans typically do not act as database users anymore. So right now, database users are applications. It's not humans, as you thought. So it would be something like this. So typically when you use Facebook, YouTube, Instagrams, TikTok, Google, what else, ChatGPT, you are not the one who directly interact with databases. The one who interact with database is the application. So it will be something like this. So as a user, as an application user, right, you interact with the applications. Then the application interacts with databases. Then database give feedback or data back to the application, and then the applications be the one who provide feedback or data back to you. So it's be like a man in the middle between the application user and the database. But let me give you a spoiler in advance. This is still not the typical way that applications work with databases. But just to give you a view that, hey, nowadays you are not database users. Database users are applications. Okay? So this is an example of the database users. You may not imagine that, hey, this code, this Python code that I hate is a database users. What? But basically, well, this kind of thing, we have the database here, right? Database is just an organized collection of data, like this products.txt, right? And we have this Python code, which is basically the one who interact with the files products.txt, right? So, as I give you a spoiler in advance, application actually is not the main characters. I mean, it's not like the one who actually directly interact with the database. But still. So even though I told you that, still, it is possible that applications can have their own managed databases. For example, use your mobile applications. Your mobile application, when it is offline, you can still access some of the data, right? Because those data are stored on your mobile phone, right? We typically call data stored on your mobile phone by the applications an offline database, right? An offline database in which some applications may directly interact with these offline databases. Some may interact with these offline databases through something else that we will introduce to you in at the end of these lectures, okay? And then these applications will interact with something that we call the application server. The application servers. The application servers will interact with the online databases. So now you see that you have two databases, two sources of data. Why do we need to split into these two sources of data? Well, imagine that there's some bad guys, right? Bad guys download these applications, and if all the applications is on all the application data is on the offline database, and if they are good enough, they can just fix all the data and make it whatever they want. I think this is a very good example for a very early offline game back in like 10 or 15 years ago that people like tend to hack, right? Tend to cheat the offline game by modifying the offline database of the applications, right? So that is why we need to have a single source of data that is shared among multiple users. Like Facebook, the Facebook doesn't store your data on your offline databases, on your browsers, on your web browser, or on your mobile applications. No, Facebook store all the posts, right, videos, medias on the offline database, and then it let you queries those data that you want through the applications, and application will ask the application servers that, hey, this dude want this data, want the list of this post, and then it will query the online database and then send it back to the user and display it on the application, right? It will be something like that nowadays. The question is, why do we need to have the application server here? The quick answer is that application needed. Most of the time, applications, they need to have some common logics, that to interact with the database, right? Common logics. So this is the same things. If you put all the logics, right, all the code, and rely on the end user applications here, if someone edit the code, they can easily change the way to interact with the online database, right? Let's say if in the application server you have the code that you increment the money by 100, right? If imagine that this code is on the end user applications, and there are some bad guys fix this code, instead of incrementing the number of money by 100, they can fix it into from 100 to 1 million, and they can easily modify the online database. So that is why we need to have the application server, so that there is a common code that all the end users applications use and must not be modified. Okay? Right, that is why we have these application servers. But as a spoiler, typically application servers are not the one who directly interact with online databases still. There will be another guys. So you can see that nowadays, when you build applications, you're typically gonna see it as layers, right? Application users interact with the end user applications. This layer, we call it a presentation layers. Why? This is the layers of presenting information to the users, right? And then right after this, it's all about presenting. But the source of data, or the computations, will be in the application server. And we call this layer the business layers, or the business logic layers. Okay? The application servers here will interact with the online database. Right? These is called the data layers. Okay? So this is an example. This is the big grade that you use. Okay? So this is all the client. Let me put out the laser pointers. So this is a client. Right? This is you that use, whether it's on laptop, on your computers, or on the mobile phones. All of you, when you open up BigGrade, you need to interact with the application server, right? Written by Rocket in Rust. Okay, the application server may interact with many things. For example, Google, in order to do the Google login things, right? The file storage, in order to, when you submit the files, right? I can store your files on this database, on this bucket. Okay, the application servers also interact with something that we call DBMS, database management system, which is basically the layer that is basically a missing piece from the previous slide, right? But this will be the one who interact with the databases. Okay, and also there will be another programs called runner, in which I written in Python and using some Docker things, container things, to whenever we receive the submit your submissions, and if that assignment is auto graded, then the runner here will read your submissions and then instantiate and then we try to simulate a small computer in my machine, in order to run your programs and see whether the outputs of the programs are expected as we want or not. Okay, and then if it is expected, then we will update the managed database with the scores and the feedback, right? If you want to know more about BigGrade, catch me up, right? Hit me up, and I will talk about and we can discuss about it. We can discuss about this. Okay, so earlier, what I want to say is that nowadays those applications, there are many layers onto it. The three main layers are the presentation layers, in which it's all about applications. It's all about websites, right? How good it looks, right, to the users. Some people love to call it a front end, right? Front end, FRONTEENT, which is the end one end of the system, but at the front. Okay, when we say at the front, it means that the end that is close to the users, right? That is a closest point to the users, right? Front end. For right after that, it will be something that we call the back office or the back end part. Okay, and then from the front end or the presentation layers, then these presentation layers thing, it will interact with the application server, which will have the share system logic, and the application servers will be the one who interact with the databases. Okay. Well, but as I gave you a spoiler before, it's not the role, the duty of the application server anymore in this period of time. Okay, so now you know that applications interact with databases, right? Maybe not directly, but they interact with databases in some way. So now I'll tell you what are the typical tasks that people typically interact with databases, right? So there are 4 main tasks. The first one, definitions. The second one, manipulation. The third one, queries. And the fourth one, access control. So the first one, definitions. As you can see in the bracket, I say that it should be only for database administrators, right? Because this is a task for defining the correctness of the database. Okay. The second one, manipulation. Is this all about editing values or adding values or deleting values or modifying values, updating values in the databases, right? A third one, query. It's all about reading values in the databases. Nowadays, query is not about reading values. It's all about analyzing values as well. And the fourth task is about access control. This is more on the security side of point of view. So it's all about which database user can do what, who can do what. Okay, so it's going to be working on granting some permissions to some database users, revoking some permissions of some database user, and in the bracket, this typically should be done by database administrators. Okay, let's see each one, starting from the database definitions. When we talk about database definitions, again, the main rule is that databases must be correct. How do we know whether the database is correct? And it's a duty of the database creators. So here I use the word creators, or the one who create database. Most of the time, database creators are the database administrators, but sometimes may not, right? So database definitions are 2 things together, combining together, at least these 2 things. Okay, the first one is a schema. The second one is a set of constraints. Database schema. The first one is a description. Is a description of the structure of the database. Well, if you read this, you may think that what the hell is a description? What the hell is a structure of a database? A structure of a database basically means if you're working with data in the table, the structures basically mean what are the columns, how many columns are there, and what are the columns, right? And what are the types for the columns, right? So it must be so somehow, if you want to say that, hey, my database is a table, you need to describe, okay, how many tables are there, and what are the columns of each table, what are the types for each column, something like that. Okay. Another one is a constraint. Constraint is basically a rule that dictates values in the database. So the first one is more on how many columns are there, right? So that you can put on, if you add new rows, you know how many values you need to put it on and the types of each values, right? But the constraint is basically a rule. It will be more flexible than the schema. Well, I'm only you might not see the pictures. So let me show you an example. So on this slide, it will be all about schema. Okay, schema, it will tell you how many columns are there, and it will also usually dictates types of the values for each column. Well, let's consider this. So this is what I call database schema. Basically, this is a table schema. Okay. So this database consists of two tables. The first table names programs. The second table names name students. For the table programs, there are two columns. The first column is code, whose type is integers. The second column called name, in which its types is a string, right? So basically, this means if we define a table like this, a schema of a table like this, it means that in this database we will have a table, namely programs, which is basically a table with two type columns. And this is the same as the students here. This is the same as the students here, where we have 1, 2, 3, 4, and 5. 5 columns in which ID is int, name is strings, enroll year is int, graduate year is int, and program code is int, right? So this is what I mean by the schema of the database. The structure, the description of the structure of the database. How many tables are there? What are the description of each table? Okay? Well, now you can dictate the types, right? You can dictate how many values should be in for each row, right? But there could be more things that you would like to dictate. For example, in the students, right? Well, for the ID, there should not be any students whose ID are empty, right? So you may want to dictate that, hey, ID must not be now. Now means an empty values, not zeros, right? Not zeros, but it is an empty values. And also, students shouldn't have the same IDs, right? Two students shouldn't have the same IDs. So another rules would be ID must be unique, right? You must not have two values, two IDs that are the same, right? Also, you have this enroll years and graduate years. Enroll years, it would be weird if it is greater than graduate years, right? So one of the constraints could be enroll year must be less than or equal to graduated years. Also, for the program code, well, we have two tables, right? We have the table that we define, that we aim to keep all the programs, right, with the code, right? So in the students, you also have the reference to the table called programs. So which means it would be nice if you saying that, hey, this program code, it must exist as a value in the column code of table programs. So these are what we call constraints. As a spoilers, the first one, ID, that is must not be null and must be unique. This is a constraint that we call a primary key constraint. Enroll years and graduate year things that it must be less than. In typical database software, we call it a check constraint. The last one here, that a value in this column must exit it in another table as a values in a certain column in another table. This one, the last one, we call it a foreign key constraint. Okay, but we'll talk about it later. Alright, actually the next step. Okay. Database manipulation. So previously we talked about the definitions, right? Now we're going to talk about the manipulation. Manipulations are insert, delete, update. Okay, these three main tasks. So data in databases, when you manipulate it, whether you insert new rows, update new rows, it should not be update new rows, update all rows with new values, delete rows, do whatever you want, but the database should still be organized as it should, and it must still be correct as we define. That's all. Pretty simple, right? Database queries. So query are trying to read, right? Or we extract some insights from databases. So database users, basically, they should be able to read data from databases. Could be all the data from the databases, or could be some of them. Typically, most applications gonna read only some data, right? But that would not be matters if your application is very small and do not have much data. So in that case, those kind of applications may read all data from databases. But most applications nowadays they're gonna read only some part of the database. That's it for the queries. You will see it in actions next week. Okay. The last one is a database access control. Again, not all users should do everything. For example, schemas and constraints shouldn't be directly altered by database users. It should only be altered by database administrators. But maybe not all database administrators should be able to alter it or alter them as well. Database users typically should be able to see only some views of data in databases. You see this word, some views. This is also some definitions, some terminologies that you may want to know, or you may want to remember. So even though database we have 10 tables, some users should be able to see only 5 of them, 2 of them, 1 of them, even in the same table. Some user should be some user. It could be better if some user can only access only some rows of the table, right? These are about access control. We will talk about it in the futures lectures and labs. Okay. Now you know typical tasks, right? Definitions, manipulations, query, and access control. Now, let me ask you: do you think humans or AI agents will be able to do them without flaws? If the data are somehow incorrect, get updated. Let's say if you ask someone to update the data, and then if this guy on that day, maybe he's sick, and he kind of like update your data wrongly, that is not acceptable, right? So let me ask you, how much can you trust humans or AI agents to do these tasks, definitions, manipulations, what else? Queries, access control. And I can say it right away that no, you should not trust humans or AI. AI, they are not 100% accurate. Humans, we have human errors. So, wouldn't it be better to hand this off to software, well-written software, and those software would do definitions. Actually, not the definitions. Would try to make database correct as the definitions people define. Would help you manipulate the database. Will help you query a database. Will help you do the access control into the database. Is a software. So instead of you write the code to do in the application server to do definitions, manipulations, query, access control, now you hands everything off to the man in the middle software called database management system, or DBMS. And we have new layers called the persistence layers. So database management system will help you do all those tasks. You only need to specify commands, APIs, right? in order to make them do those tasks for you. So DBMS is basically a software doing those tasks, database management tasks. It will typically gonna provide two kind of interfaces. The first one is the network interface, in which this is the most exposed by most standalone database management system. Well, what the hell is network interface? It's more like you can connect to those DBMS but through some networking protocol. Networking protocol is more like a specific command. Let's say a specific command through network, to computer network. Or there are another kind of database management system, that expose interface as an API, application programming interface. We call them the embedded database management system, or the in-process database management system, which basically, it's like when you read in a Python program, you just need to import the modules and then use the modules to interact with the database management system in order to hand the tasks to them and then let them do the database management task. Okay? Well, when we talk about interface, right? So if you're gonna do the network interface, applications mostly need to specify the network locations of the DBMS process, right? We have the term process here. The term process here means running programs. So database management system is basically a software, right? A programs that must be running. So whenever you want to interact with the database management system through the network interface, you need to specify the network locations of the DBMS process. The network location is basically an internet protocol IP and the port of the database management system, right? And the DBMS process, right, the running programs of the database management system will be running as a standalone server. So this is for the network one. For the API, again, as I told you, most of the database management system will provide libraries for the programming languages that you want, for example, Python. And you just need to import it and use the functions, classes that they have implemented for you. And those functions and classes, it will interact with the database management system. And some database management system provide both interfaces. As far as I know, DuckDB does this, right? It has both network interface and the API interface. Okay. So now you can connect through the databases to the database management system through interfaces. The only thing that applications need to do is to send database commands through the interface. Those commands are typically called queries. Queries are commands, right? So you need to describe the commands in order to help you describe it clearly and less ambiguous. Queries are often specified in domain-specific languages. Typically, they are not common programming languages. They are more domain-specific. They are like languages that are built specifically for a specific domain. And in this part, it will be languages that specifically built for interacting with the database management systems. The example of these languages are SQL, 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 QUEL, Cypher, GQL, GSQL, Gremlin, GraphQL. What else? Yeah, There's a lot of them, but the most popular one are the SQL, and these are the example. So this is like the command that as an applications you need to send this kind of commands to the database management system in order to let them do something for you, do those database management tasks for you. Right, this one, if you retrieve, if you read the entire table from the database managed by the database management system, this one is another way to write the SQL, but it will be something like this, in which we will have 4 labs on this SQL language, and we will have 1 exam on this as well. So you really need to be familiar with it. Okay. So in summaries, nowadays humans do not typically interact with databases directly. DBMS does it. Database management system, or DBMS, are systems that do all the management tasks on behalf of us, either application users or the end user applications or the application servers, right, on behalf of us. But typically, you still need to do database definitions and a query from the application side in order to interact with the database management system, and then let them do the tasks for checking whether database are still correct, and for reading some data from the database managed by the database management system. If you have time, I have another lecture from another course that I am teaching, the big data, and we talk about the evolutions of data technologies. I believe that based on your capabilities right now, if you understand what I'm talking about so far, you may be able to watch it. Okay? And next week, we're gonna get into DuckDB, which is the database management system we're gonna use throughout this course. Okay? I will ask TA to use this kind of interface. It is a very fancy interface. So you can see that, oh my god, this is actually, so this is the interface, the graphical user interface for the database management system. And you can specify in this part, in this part, you can see on this part, you can specify the command in this SQL language in order to send tasks to the database management system or to DuckDB, and let DuckDB do the task for you. And those SQL will be taught by these 2 guys, right? Our SQL veterans, right? So we have P1 or อาจารย์น้องหนึ่ง and we have Indie, right? I mean, I don't know why Gemini generate the picture is cooler than they are. Well, maybe they are this cool, right? Okay, so that's it for today's lectures. If you are reaching this point and you haven't found any quizzes, you may miss it. You may skip some part of it. So search for the quizzes. You need to do the quiz in order to gain the point for these lectures. Okay. So that's it for today's lectures. Next week will be the labs, and weeks after that we will meet each others in Thailand. All right. Thank you so much.